My name is Sean Conrad. I do developer relations for Secret Network, and I'm extremely excited to be teaching this tutorial today, which is how to deploy your first dApp on Secret Network. So what we're going to be doing today is learning how to upload and instantiate your first contract on Secret Network Testnet, which will be a basic counter smart contract. We'll look at the contract briefly to understand working with entry points on Secret Network and Cosm Wasm. And from there, we will install a React frontend and just create some very basic buttons to be able to upload or to be able to increment and query the counter smart contract, and also to have Kepler wallet connected to our frontend. So let's dive in. Brief review: if you're brand new to Secret Network, Secret brings private smart contracts to the Cosmos and beyond, to Ethereum and Solana and other blockchain networks through the use of TEEs, trusted execution environments. We're now connected to EVM and Solana, but that's a little bit bigger than what we're going to be learning on this tutorial. But just know what you're learning today, what you're learning to do on Secret Network. You can also bring this confidential computation layer to other blockchain networks across Web3. So let us dive in. We're just going to be going through the docs exactly as they are. Really, what I want you to understand from this tutorial is how to use Secret Network docs to the best of your ability. And we're going to be looking at two main things, which is our actual docs here in the Getting Started section, specifically the compile and deploy on Secret Testnet section, as well as Secret.js. And Secret.js is a JavaScript SDK that allows developers to do various functionalities with secret contracts, such as uploading and executing secret contracts. So let me just pull that up here. Here we go, Secret.js. Great. All right. So what is Secret.js? Secret.js is a JavaScript SDK for writing applications that interact with the Secret Network blockchain. It's written in TypeScript. It provides simple abstractions over core data structures, and it handles input and output and encryption and decryption for secret contracts. So by the end of this tutorial, you're going to learn how to add Secret Network Testnet to your Kepler wallet, how to optimize, compile, upload, and instantiate a secret contract to a secret testnet, and then get that actually connected to a front end. So let's get started. The first thing we're going to do is just download the counter contract itself. So let's just actually take a look at that just to see. This is the repository that we're actually going to be downloading to our computers. It's a template created by Secret Labs, who are the developer team behind Secret Network. And what it is just a basic counter smart contract that you can increment, and you can query the current count of the contract. So we're just going to use this command here, cargo generate. And if you've never worked with cargo before, or the command cargo generate, you might just have to install cargo to your computer to be able to use that command. So I have CD'd into my desktop, and now we're just going to run cargo generate to pull down that counter smart contract to our computer. Okay, great. So I have that there, and now I'm just going to open it up in my code editor. Wonderful. So before we actually compile and upload the smart contract, let's just take a look at what we're actually working with. When working with Cosm Wasm smart contracts, which is the SDK we use to write Secret Network smart contracts, the best way to start is to always look at the message file. You'll see that our contract is broken into 4 parts in our source folder here. We have contract.rs, lib.rs, message.rs, and state.rs. So lib is short for library. All that it does is just sort of organizes the other files in our contract. That's all that file is. Then we have a state file, a contract file, and a message file. State is where we store the state of the contract. Contract RS is like the actual logic implementation for our smart contract, and message is like the actions that the smart contract actually takes. So what I like to do whenever I start working with a smart contract, whenever I pull down a repo, is to open the message file first, because this is where you can actually understand what the contract is doing. It's the actions that it takes. And so here we have in our execute message enum, we have increment and we have reset. So we understand that this contract probably has the ability to increment account and reset account. We also have our instantiate message. So when we instantiate the contract in the blockchain, we need to have a starting count that it starts with. And then we have the ability to query the count with this get count method, which returns this struct count response. Okay. If we look at our state, we'll see that when the contract has an owner and it has a count that's stored, starting count when we instantiate it. And then we just have some other basic storage objects here using this CosmWasm component called a singleton. Okay. And then if we actually look at our contract, we'll see it's very simple. We have here, 130 lines of code. We have an instantiate message where we're pulling in that state object we just saw, that where we have a count and an owner. So we pull from our message parameter to store that count, that starting count, and then we store in our state object an owner for the contract, which is the wallet address that is instantiating the smart contract. And we pull that from our info parameter here. All right. And then again, we'll see we have these two basic functionalities, which is increment and reset. And all of that logic is already written out for us. It's very simple stuff. And if you have any questions about that, I guess when you see this on YouTube, on DoraHacks' YouTube channel, you can just post a comment and I will respond if you have any questions. And you can also message us on Discord or Telegram in our developer channels. So now that we kind of have a basic understanding of what the smart contract is actually doing, let's compile it. And we can do that with our make file. Make is a compiler we use for, I think, Rust and C++ smart contracts, or not just smart contracts, but that's what we're using it for in this capacity. So we see we have various commands already pre-written, one of which is make build mainnet. And this just compresses and compiles our contract so that we can actually upload it to the secret network blockchain. If you don't have make installed on your computer, that's another prerequisite for this tutorial. So you might have to install make to run this command. So I'm just going to run make build mainnet to actually compile this smart contract. We'll see that it's compiling all of our dependencies. And all of the imports for our CosmWasm smart contract, for our secret network smart contract, that's all pulled in our cargo toml file here. So everything we're using here, everything we're pulling from the CosmWasm SDK, you'll see we have this tag here that directs it to a specific secret version of this repository. And we'll see, yeah, so Secret Labs here has their own branch of CosmWasm, which is what we're using and importing into our smart contract. All right, so that's been compiled, and now we see our compiled smart contract here. We have contract.wasm as well as contract.wasm.gz. GZ is the one that has been condensed. This is the smaller file, which we're actually going to be uploading to the blockchain. So let's do that. I'm just going to create a folder called node where we're going to be installing all our secret.js files. So I created that folder called node, and then I'm just going to create a file called index.js, which is where we're actually going to create the commands to upload, instantiate, execute, and query our counter smart contract. All right, so now we'll see that I have a folder here called node. Oops, I forgot to cd into node, so I'm just going to drop that index.js file into my node folder. Let's cd into node. I'm going to create a blank package.json file so that we can install secret.js. Okay. I just did that with the command npm init y. All right. And the only other change I'm going to make to this empty package.json other than installing secret.js is creating this type and setting it to module. And all that does is when we set our package.json to module, the type field allows a package to specify all JS files within the ES modules. If we don't do that, all files are treated as common JS, but we want to do this for ES modules. All right, so I'm going to actually install only two things. I'm going to install secret.js with npmi secret.js, as well as .env, so that we can work with our wallet mnemonics. If anyone has any questions at any point, just let me know. Great. And for anyone who maybe joined late, I'm just walking us through the secret docs, specifically the getting started section and the compile and deploy on secret testnet. So we're just doing exactly this. I just downloaded this GitHub folder with a basic secret network counter smart contract template. And now what we're going to do is upload and instantiate the contract on secret testnet. And all the things that I'm teaching here, they're also written out here. So if you're less of a visual learner and you want to just go straight to the docs, you can do that. So we just compiled the code. Now we're going to upload this contract. And let's just pull from these docs to do this. So I'm going to copy this. I'm going to go to our index file. And here what we see is we are importing secret network client and wallet from secret.js. We're importing .env. We're going to access our wallet here. And we're using FS to actually read that contract.wasm GZ file that we just compiled. That way, this is what we're actually going to be uploading to the secret blockchain. Let's just create that mnemonic file really quickly. And let's just imagine that whoever's listening here has never worked with a secret wallet before. So that way we can just actually create a new wallet and fund it. Which I think that should all be here in the docs as well. I'm curious. Oh yes, learn how to configure and fund your Kepler wallet here. Okay. I'm going to take us from the very beginning. So let's just pretend we've never worked with Kepler before. We're going to download it from the Chrome Web Store. We're going to create a new wallet with a new recovery phase. Okay. And let's just actually import that into our okay. So can we add secret testnet here? Let's see. Yeah, add secret network, not testnet, I guess. All right, let's check it out. Okay, so now we see we have our empty Kepler wallet. Let's just request funds from the faucet. This is just adding secret testnet to our Kepler wallet. And then here's the faucet. So just copying my address. Mhm. Actually, all right, so that's my address. We are going to send some funds. Great. We should see those tokens now. Wonderful. So now we have 100 secret testnet tokens, which will be more than enough to upload, instantiate, and execute our contract. If anyone has any questions about that, that's all here in the docs. So right here, you learn how to configure and fund your Kepler wallet. It's all part of this exact tutorial we're walking through. Okay. Gonna just clean this up. So let us upload the contract. We've already written an upload script here for you to be able to pull in. Oh, actually, before we do that, you have to get connected to Secret.js. So this is our secret network client right here. It's just, we set it as an object called Secret.js. And the main thing to note here is that we are using the chain ID pulsar3 and the URL api.pulsar.secrettestnet.com. This way, we're working with a secret network client that is specifying we're working with secret testnet. If we use the chain ID for mainnet, which is just secret4 and a URL for mainnet, we would actually be uploading our contract to directly to mainnet. That's the only difference. If you want to do this for testnet versus mainnet, you just have to swap out the chain ID and the URL. And the chain ID and URL info is all in secret network docs. But now, like if we just console log Secret.js, we can see that we have a working client. So let's just do like .address, and we'll see my wallet address. Or we want to say .wallet address. I'm just going to run this with node index, and it's undefined. Why is it undefined? We have done. Interesting. Well, okay. What if we just do? Oh, okay. Okay, nice. You just have to secret.js.address, that's all, instead of .wallet address. All right. So we have our secret network client set up. Now let's actually upload our contract. And so we already have scripts written for you to upload your contract, for you to instantiate it, for you to query it, execute it, all the things that we're going to be doing. Everything is pre-written for you. So let's just take this upload function, copy it in. And the first thing we're going to do is upload our smart contract. So we'll see our transaction here. It's just using this transaction.compute.storecode method. And we're specifying things like the contract file itself. So we're pointing it to that compiled WASM file we compiled earlier. And that the sender, who's actually uploading, is my wallet address. And then we're going to return the code ID and the contract hash so we can use that information to instantiate the smart contract. So I'm going to run node upload, or actually node index, my bad. Great. And then that code ID and that contract hash is returned, which we're going to use to instantiate the smart contract. So I'm just going to comment out upload, and we're going to add our instantiate script. And you'll see here that we have we need to have a code ID and a contract code hash. So let's just create those variables really quickly and replace with our actual code ID and code hash. So the code ID we have returned is 10,368. And what that actually means is that this is the 10,368th smart contract someone has uploaded to the secret network testnet. And that's just this iteration of the secret network testnet. There's been previous iterations. All right, and then our code hash is a string. Wonderful. And remember I said that our counter smart contract has an instantiate message with a starting count. Like if we go back to source message, we'll see that here we have the starting count. So this is the count that we want it to start with. So let's do that. Right now, our starting count is 0. Let's make it 17 for fun because today's September 17th. And then let's run the instantiate script. And just a smart contract address should be returned if it's successful. So we log this contract address. Awesome. Our contract address was returned. Let's take that. I'm going to comment out instantiate. Okay. Now let's work with this contract address. So we should be able to do two things, right? Which is upload or execute the smart contract and query the smart contract. Let's run the query script to see what the starting count is, which should be 17. Oh, make sure I name contract address correctly. All right. So all that this is doing is it's pulling from that contract address and that contract code hash we have here that we just instantiated. And then it calls the get count method to query the current count, and then it logs the count. So if we try query count, we should get 17 back. Awesome. You see our current count is 17. Now, let us execute the increment message. I'm copying that in. Okay, and so now we're calling the execute contract method with secret.js. We'll see we're using the sender is our wallet address, the contract address and code hash are our contract address and code hash, and the message that we're calling is increment. And instead of just logging incrementing, let's actually log the transaction info because I think that's more interesting. So we're just going to log this exactly here. So I'm going to call node index. Amazing. And we see all the transaction info that comes with that transaction. And then if we query our count once again, it should now be 18, because if we go back to the logic of our smart contract, when we call increment, what it does is it takes the current state and it increments it by 1 and then returns that new state after it has been incremented. So let's run node increment. And we now see the count is 18. Awesome. So I'm now going to connect this to a React frontend. That's going to be the next portion of this. Before we move forward, does anyone have any questions about what we just learned with compiling a secret network smart contract, uploading, instantiating, executing, and querying the contract on chain using secret.js? No questions? All right. So I'm going to create just a blank React frontend. So npx create React app, and this is going to be called contract demo. So this is just creating like a React template app, which we're then going to turn into our counter contract demo app. So I'm going to get some coffee really quickly while this downloads. It should take like 30 seconds. Great. And so it's all just been downloaded into this contract demo folder. So let's just cd into that. Let's install secret.js, because just in the way that we used it in our other npm package, we're also going to use it in this React npm package, so we have access to the secret network client. And if we just run npm run dev, scratch that. If we run npm run start, we will see the basic React starter app. Okay. And then I can just make some changes to that very quickly. I like to just get rid of these basic, kind of some of the stuff we don't actually need. You don't need web vitals. You don't need this test file. And we don't need this logo file. So I'm just kind of simplifying this for us. And then let's just create a header called counter tutorial for secret network. So now if we go back, cool. This is all that we have right now. It's just this header. And we're just going to create two buttons that console log the count, the current count, and then also once we increment the count, it will show the transaction info in the developer panel. All right, let's just make those buttons real quick while we're here. Okay. There we go. And now, so if we go back to secret.js, so the secret.js docs, and we search for Kepler, we can just take this Kepler code. So this is how to connect a Kepler wallet to your front end. So I'm just pulling this exact code from the secret.js docs, bringing it back into here, into our app.js file. And basically now what we're going to do is just take what we created in our index.js file when we were just working with Node and pull that into our app.js file now that we're working with React. Okay. It's just going to give us this little error because we're now working with JS instead of TypeScript. Okay, this is being, let me just close this out real quick so it stops being annoying. And you'll see that we're working with chain ID secret 4, which is mainnet. We don't want that because we want to connect our app to secret testnet. But if you wanted to do mainnet, that's all that you would do is just use chain ID secret 4 instead. But we want to use the files we specified here to properly set up our secret network client for secret testnet. So I'm going to pull the chain URL from here, bring it back into here. And now everything should be set up correctly. to connect our React app to our front end. Let's see. Okay. So I'm going to run this again. Okay. So now our app is connected to our Kepler wallet. That's cool, right? All we had to do is paste in that Kepler code, and then it automatically has this Kepler pop up now whenever you log on and your wallet is not currently connected. So the last step is just to actually add our increment and our query functions in here that we already have written, and just have it so that when you click on the button, it actually does those tasks. So let's just pull those in. Okay. Oh, and we also just need to bring in our contract code hash. Wallet is not defined. Guess that's because the sender is wallet.address. But instead, we are destructuring the wallet here and calling it my address. So I think it should just work if we take my address instead of using wallet.address. Let's try that, see what it says. All right, it's not screaming at us. So let's actually try it. Let's open up our developer tools. And if we query, we should get the current smart contract count state, which should be 18 because we've only incremented it once, and our starting count was 17. Oh, duh. I have to connect these buttons. So button on click is equal to try increment count. And this is called try query count. Now when I click this button, what it should do is on click, it should increment the count. And when I click the button query, it should query the count. Let's just see if that's working as expected. Yay, 18 is returned. Let's try incrementing it. And then you see we have to approve it with our Kepler wallet. And then that transaction data should be returned here in the console. There you go. See the transaction hash. And what's awesome is we could actually just like query. We could take this transaction info and we could go to an explorer like testnet.pingpub, and we can actually see that transaction information on the explorer. So let's see. Not recognized. I think it's because there's this quote. Awesome. So all that info that we just returned in our console, we can also see here on a public explorer. Pretty cool. And now when we query our count, it should be 19 instead of 18 because we just incremented it. Let's see. There you go. All right, everybody, that is our tutorial on creating your first ever secret network dApp. It might have been a review for some listening, so I appreciate your patience. But today, what we learned is how to compile a secret network contract, how to upload and instantiate that contract on secret testnet, and then how to actually upload and query, or how to execute and query that contract. And then we also learned how to connect all of that to a React frontend with Kepler wallet. Does anyone have any questions before we wrap up this developer tutorial session for DoraHacks and Secret Network? Okay. Thank you, everybody, for listening. I've been Sean Conrad with Secret Network. I'm part of the developer relations team, and I can be reached on Twitter at Secret Seanrad, as well as on the Secret Network Discord developer channels, such as dev discussion or dev issues. And we're also on Telegram at Secret Network Community. I want to thank DoraHacks for being such a great partner, and I'm very excited to see what everybody builds in HackSecret 4. Thanks so much, everybody.